Black holes are weird and mysterious, and they keep astronomers and scientists super interested. They're basically cosmic vacuum cleaners with such strong gravity that not even light can escape. Physics, as we know it, kind of breaks down around them. Einstein thought them up way back in 1916, but they were just a theory until we got tech good enough to spot them indirectly. Then, in the 60s, some scientists saw this strange thing. A bright blue star shooting out a ton of X-rays. It was orbiting something invisible and heavy. Turns out it was a huge black hole called Cygnus X1. Finding Cygnus X1 was a big deal. It proved black holes are real and kicked off a new wave of research. It's about 6,000 light-years away and crazy dense. That gravity is so strong that nothing gets away. That's why we call it a black hole. We've since found tons of black holes all over the universe. The Milky Way might have over 100 million. They're tough to spot, but scientists have found some good candidates, from smaller ones made when big stars die to super big ones in the middle of galaxies. Black holes have a big impact on their surroundings. Their gravity messes with how space systems take shape and how stuff moves around them. If anything gets too close, it's doomed. It gets pulled in, stretched like spaghetti, spaghettification is the term, and then swallowed up by the singularity at the center. Even though black holes are great for pushing the limits of physics, they're still pretty mysterious. We want to figure them out to better understand space, time, and gravity. They're like silent guardians out there, daring us to learn more. The nearest black hole is about 1,500 light-years away, but people still wonder what would happen if they were closer. In 2021, we got the first actual picture of a black hole, M87, in the middle of the M87 galaxy. It was a huge deal. It showed that black holes aren't just empty voids. They have layers. Researchers now think there are three main parts: the event horizon, where there's no turning back; the photon sphere, where light gets stuck orbiting; and the singularity, where physics goes haywire. All black holes seem to have these layers, but they're also unique. This makes them hard to study. We can't just send probes in. They'd get destroyed. So scientists have to study them indirectly. They have theories about how black holes form, from collapsing stars to stuff happening between galaxies. NASA's been looking at the center of the M87 galaxy. Their work seems to point to a super big black hole calling the shots. Even with all the problems, curiosity keeps scientists going. Black holes may be puzzling, but we won't give up on trying to understand them. Back in 1963, Roy Kerr changed how we think about black holes. He came up with the idea of rotating black holes and introduced the ergosphere. It's a zone around the black hole where forces balance out. Kerr's model also suggested something: wild wormholes. These are like tunnels through space-time that could link different parts of the universe or even other dimensions. General relativity says that space and time are like a fabric that can be bent. Wormholes would be shortcuts through this fabric. But are they real? That's up for debate. Wormholes get people excited about space travel, but there are problems. They might be unstable, mess with quantum stuff, and have tons of radiation. Plus, even if they worked, relativity says we might not be able to travel faster than light anyway. Still, wormholes are cool to think about. They're a reminder of what's out there and get us thinking about other universes. Which brings us to the theory of everything, a way to unite gravity and quantum physics. Superstring theory is a big idea here. It says that the basic building blocks of matter aren't particles, but tiny vibrating strings. Think of it like a musical instrument. Each string vibrates at a certain frequency equal to the particles and forces we see. Superstring theory might explain black holes, wormholes, and gravity. These strings could create gravitational weirdness as they move through spacetime. The problem is that string theory is hard to test. It also needs extra dimensions that we can't see. Imagine fish in a pond. They only see two dimensions, not up and down. These extra dimensions are thought to affect everything, even if we don't see them. Even though it's theoretical, string theory has gotten people interested in math and science. It's helping us figure out how complex systems work. But so far, we have no real proof, so it stays theoretical. Still, people are inspired by the knowledge. Finding out how quantum physics and black holes work together has always seemed impossible. Physicist Edward Witten even said that string theory is 21st century physics that fell into the 20th. But now there's progress. Some teams think string theory could have an answer, at least in simple situations. This is cool, but we still have lots more to figure out. Trying to unite physics makes us question what we know and consider some wild ideas. Learning about black holes changes how we see the universe and makes us think about what's really out there. How they mess with things like neutron stars and gamma ray bursts shows how wild and powerful our universe really is.